Welcome to this tutorial, which will provide an overview of the Metricus process miner. We'll look at the various components and discuss basic functionality. Additional tutorials on the Metricus website go into further detail on capabilities such as the process visualizer, slicing and filtering, and performance, cost, compliance, and automation management. There's also a tutorial available to understand event logs, which represent the data source for process mining. For this tutorial, we'll be analysing incident data from ServiceNow. The process mining experience begins with the process visualizer, which provides an X-ray vision of a process. The variant grid can be used to select one or more variants, and by default, the top 10 variants based on task volume are displayed. A variant represents a distinct set of activities within a process, with the transition from one activity to the next being known as a step. Multiple options are available for highlighting steps in a process. The default is duration, which highlights high average duration with red and low average duration with green. Similar logic applies for volume, standard deviation, and cost. Steps that are loops or non-compliant or automated can also be highlighted. These are specified by process rules, which we'll discuss later. The width of the line representing a step defaults to the volume of tasks associated with the step. This can be changed to the average duration or standard deviation. Filters can also be applied to show variants containing loops, compliant steps, or automated steps. By using the variant graph, individual variants can be animated, isolated, or their life cycle displayed. All grids contain multiple metrics that can be filtered and sorted to assist in identifying process issues. Let's expand the variance grid by using the sliding panel. We can view the columns available and select columns using the columns pop-up menu. Filters can then be applied using the filters pop-up, and columns can be sorted, moved, and resized. Hovering over a step will display a tooltip with key metrics for the step. The metrics displayed, as well as many other process visualizer options, can be changed in the Settings Visualizer pane. The layout of the visualizer can be changed. The column and layer spacing can be set. You can select which labels to see on steps, whether to show the label on the start and end steps, the font size of step labels, whether to show the start and end label, the node labels to display, and the font size of the node label. The duration format can be changed, and all the colors in the visualizer set to your preferences. There is also the option to automatically zoom the visualizer to fit when different variants are selected. This is in addition to being able to use the mouse scroll wheel to resize the visualizer and being able to drag the contents if necessary. Another visualization for variants is the variant lifecycle, accessible via the variant lifecycle action button. The step metric determines the length of the bars associated with steps, and similar to the visualizer, the variants to be displayed can be selected via the variance grid. The variants displayed can be filtered using the slices pane. Here we can slice by steps. For example, we may just want to look at variants where the step goes to the assigned activity. Or we can reset the slices, access the activity slicer, and look at all variants where the step starts or ends with the assigned activity. Another way to slice variants is by the path slicer. Here we can choose combinations of steps based on precedent. The Filters pane allows you to filter the underlying event log to only include events and tasks with certain characteristics. For example, we may only want to look at tasks of a particular category, or tasks created over a certain time period. We can also filter on metrics within the event log. In the case of incidents, we can filter to only look at tasks where the Met resolve SLA is false. Often an event log is processed and there are significant outliers. These can be removed by accessing the task filter. For example, we can choose to only look at variants that have at least 10 tasks. Context menus are available for variants currently selected, individual activities, and steps. These contain a range of options to drill down and investigate tasks and events associated with the selected variant activities and steps. The Analyze Context menu option provides different types of AI-driven analytics. These include a decomposition tree, automated insights, influence analysis, and task lifecycle visualizations. The decomposition tree provides guided drill through of the selected event data based on the metrics available and attributes. Metrics can be sorted, and minimum and maximum values set to refine the selection. Insights automatically detect groups of anomalies for metrics based on the task attribute selected. Influence analysis highlights the relative influence of different groups of tasks. The task lifecycle visualization shows the lifecycle of tasks associated with the selected activity or step. The duration deviation of the tasks and events associated with selected variants, activities, or steps can be analysed via the histogram context menu option. The details of tasks associated with a selected variant, activity, or step can be viewed by accessing the detail option within the context menu. When visualizing a process, the steps related to an activity are those within the displayed variants. To analyze all inbound or outbound steps for an activity, access the context menu Inbound/Outbound Steps option. The Metricus process miner contains a unique rules engine to optimize process cost, compliance, automation, and performance. There are two main types of rules that can be defined: cost and process. Process rules can relate to compliance, automation, or performance. They can highlight an issue or opportunity, or they can relate to an improvement goal and associated cost savings. First, we'll look at cost rules. These allow for the calculation of step costs and therefore the calculation of the overall process cost. To create a cost rule, right mouse click on a step in the process visualizer, or right mouse click a step in the Slices Steps grid. For this tutorial, we'll define a cost rule for the assigned to resolve step. Rules can be defined for all variants, selected variants in the process visualizer, or the current sliced variants. The tasks associated with the rule can be all tasks or the tasks currently filtered. Costs can be for the total cost of a step event, the cost per minute, hour, or day, or the cost determined by either a related cost based on task or event attributes. For example, the cost per hour for the resource associated with the step event. We'll create a simple cost rule that says the cost is $50 for this step. Once a cost rule is created, the metrics related to costs can be highlighted by selecting the Cost Mode button. Currently defined cost rules can be displayed by accessing the Cost Action Bar button. Analytics are available to show various cost metrics based on defined task and event attributes. And root cause analytics can be leveraged using the cost metrics available. Cost metrics are also available for analysis, sorting, and filtering within data grids. Like cost rules, process rules are defined by either right mouse clicking a step in the process visualizer or right mouse clicking a step in the slices steps grid. In this tutorial, we'll work through setting up process rules in alignment with the underlying process we're analyzing, incident resolution within ServiceNow. First, we'll create some compliance rules. Incidents that go from an unassigned state to a resolved state have not followed the correct process path and should be marked as non-compliant. As with cost rules, the underlying events can be filtered based on the variance sliced and tasks filtered. Two additional attributes can be applied: the task duration and an option to calculate the cost impact of the rule. For compliance rules, this means that if an actual cost exists for the step, the forecast cost is set to the actual cost, as you're specifying cost savings if the non-compliant step is eliminated. We'll discuss the cost impact of rules further when looking at performance and automation rules. Incidents moving direct to a resolved state should also not occur, so we'll create a non-compliant rule for these events. Note that if any events within a task lifecycle are non-compliant, the task is flagged as non-compliant. Compliance metrics can be accessed via the Compliance Mode button and the current process rules displayed via the Process Rules action bar button. For each rule, the number of tasks and average impact is displayed, and the rule parameters can be accessed by expanding. As with cost rules, compliance rules create compliant metrics that can be analysed throughout the analytics and grids available. Automation rules allow you to specify which steps are currently automated or are planned to be automated in alignment with digital automation initiatives. In incident resolution, the resolve to close step is typically automated, so we'll create an automation rule. Digital automation may apply to only certain types of tasks or cases in a process. Let's filter on tasks that are assigned to the help desk. And that are category, add, install, move, modify. We'll now mark the assigned to resolve step as automated, meaning that an automated procedure will be in place for the filtered tasks. We'll also check the cost impact attribute as we have put in place a cost for this step. Moving to the process rules section, we can now see that the cost savings of automating this step for the filtered tasks is $12,800. Performance rules allow us to identify inefficiencies within a process, as well as calculating the cost savings if performance is improved. First, we'll create a couple of performance rules related to highlighting inefficiencies. The first will be for incidents that take longer than 7 days to move from resolved to closed. Once the rule is created, we can access any of the root cause analytics that will tell us what types of tasks are associated with the performance rule. The second rule related to inefficiencies will be for high priority incidents that take more than 6 hours to move from assigned to resolved. Previously, we created a cost rule for the assigned to resolve step. Let's now create performance rules related to this step and see what cost impact these rules have. For instance, assigned to the help desk, we'll estimate that the duration for the assigned to resolve step can be decreased by 50%. Looking at the process rules, we see that this results in a cost saving of over $80,000. We'll also create a rule for incidents with category equal to access and an assigned to resolve duration reduction of 30%. At any time during the creation of rules and simulation of cost savings, analytics can be accessed to provide insight into the current process status. Cost and process rules can be saved, along with the visualization settings and related slices or filters. Rules can also be edited and deleted. This concludes the Metricus Process Miner overview tutorial. Thanks for watching. For further information, additional tutorials and free trial sign up, just visit the Metricus website.